Let me get my data in. What did? Me yelling in your ear? Oh, I'm sorry. I didn't mean it to. I don't mean brain hurtage.
But it's good we did it in class.
Well, yes. That's kind of the reason. Again, as I teach this course, I've taught it for like 5 or 6 years now here. I've changed the way I've taught it. It used to be I started with the data sheet.
Yeah.
And I would collect more data, take data sets out, put data sets in, but I never had a template. And we would do all these steps without a template, and the students got more and more frustrated because they weren't having a hard time figuring. The template has really been helpful in guiding what you need to do. All right, we'll come back to the errors at the end. Let's get the mechanics down, and we'll deal with the errors momentarily. I gotta edit some data first. Man, use your data sheet real quick, Veronica, if you don't mind. Thanks. Let me get the same thing, you guys. 17 and a half, 22 and a half, and so forth. Oh, I love these numbers because Veronica's picking the halfway point. Exactly what you have to do. Delete these, don't need those anymore. And what I'm going to do, just to save time, if it's okay with you guys, I'm going to put the individual's data in L2 and the COPS data in L3. That'll save us a little bit of time, right?
Oh, you don't even have to put the speeds back in, right?
No, because you're going to use the same speeds for both, right? Assuming they're indexed the same.
But I'll miss.
Here we go. Thank you, ma'am. Alrighty. So I think we're ready. We have our hypotheses. It's going to be the same hypotheses for the COPS and the individuals. Austin's got a good point I'll come back to about the COPS hypothesis. You might want to make the COPS hypothesis be different. I want to come back to that. So let's do the individuals first.
Your data was incorrect.
Was it?
Yeah, your 6 needs to be a 9. 5, 9.
5.
On L2.
Oh, this is 5, 9. Thank you.
Yeah, it's a 9.
Thank you, Alan. Much appreciated. Anything else okay? Or go any further? Thank you. Thank you. Sweet catch.
Just like it.
Excellent.
We always have.
I know. Damn rule. Okay, so we definitely have data again, although the stats are still showing from last test. So I'm going to go over to data. Make sure you update your mu. Your new mu is 30. And this is an easy mistake to make, right? Put in 100, put in 83. It's very easy to make, and if you get crazy p-values, that might be why. So we're testing against 30 because that's the center of our curve over here. That's the center of our null curve. The list where my data is L1, and since I'm testing the individuals, the frequencies are in L2, so I'm okay there. I'm trying to see if they're significantly speeding. So are they significantly greater than 30? Okay, let's find out. I don't know. Mathematically, are they significantly greater than 30? Here comes the curve. If I get any area, it'll be on the right side, because that's where I'm shading, is off to the right side. I got some. There it is. But it's not a whole lot. It's not a whole lot. I got a test statistic of 2.4. So my question is, ignore the p-value for a second. Does this mean the cars are averaging more than 30 miles an hour? It has to, doesn't it? Good. I like the 2 standard deviations. Very nice. 2.5. Nice. Just think about how it's constructed. It's x bar minus mu. The only way that thing can be positive is if x bar is bigger than mu. So yeah, they're going faster. They're going faster than 30. The question is it significantly faster? And the answer to that is yes. Yes, that p-value is tiny. It's just under 1%, which is definitely less than 5%, which might not be what you want to use. We'll come back to that momentarily. So the conclusion for the individual is that it appears the cars are speeding. Of course, we could have had could be false positive, could be a type 1, could be a false positive, but the data appears the cars are speeding. Fair?
Yeah.
Okay, so it's more likely, I'm going to draw some curves with yellow. There you are. It's more likely for this data, for the individual's data, it's more likely for the individual's data that there's some curve over here that represents the average speed of those cars, and it's more likely we're on this curve than we're on this curve, which is basically what you guys just tested mathematically. Cool? How about the COPS data? How about the COPS data? Run the exact same test, but use L3 instead of L2 for frequencies. The test is identical, yeah? We're still testing it's greater than. Now, Austin had a question. He's like, wait a minute, what if the cops are trying to... What if the cops have said they're not speeding, so they want to prove the cars aren't speeding? I would still do it the same way. I would try to show they are speeding and show that that can't be supported. And if we can't support that they are speeding, that means they must not be speeding. So, here we go. Again, it's going to shade the same side. But what happened? We got a lot more area this time, yes? So for the cops, which curve do we appear to be on? Say that again, nice and loud. It appears that we're more likely on the null curve, because assuming this is the center of the research curve, it's so close to the null curve, there's no difference. They're too close together to be called different, yeah? That's kind of what we're getting at here. They're too close together to be called different. Now, what I find interesting about this data is both of the data sets have almost the same average, don't they?
Yeah.
They almost have the exact same average. Why is the individual's data more significant then? Say it nice and loud, guy. I got goosebumps. Larger sample size, which forces the curve up, which forces the tails down, which forces the same distance away to be more significant. Which is why I thought Alan might contest me a little bit and say, well, how is it just because you saw it over a larger sample size that the average is only 2 or 3 miles an hour away? That's not practically significant. To which I say, yeah, you're right. It might not be, but it's statistically significant, which is the only thing I can measure. The reason I bring this data up, and then we'll let you go, the speed limit on Archie Briggs used to be 25. Then they raised it to 30. And it appears that cars aren't obeying 30. So what's going to happen next?
35.
I'm nervous about that, Josie and Austin. I'm nervous about that. And as a biker, because there's also zero shoulder on that road, if you may have noticed. There's zero shoulder, and the shoulder that's there is often covered in cinders. So please don't hit me if you see me on that road. I've been taking the trail up through Sawyer Park, which is steeper but safer, I think. Even though one day last term I found, did I tell you about the baby carriage I found out there at night? Empty baby carriage on the trail in Sawyer Park. Scared the shit out of me. I'm bombing down that trail, listening to music. And I come, you get that trail, you know the trail I'm talking about? It drops into Sawyer Park. It's a really skinny trail on the cliff. And it drops down, it switchbacks a couple times, and it dumps you on the river trail, and it dumps you to Sawyer Park. And it's like 5:30 at night, I get my light on, sing all the painted black, and I come around this corner, and there's a baby stroller in the middle of the trail. Whew, my heart stops, I drop the brake, grab the headlight, walk up, not wanting to find anything in the stroller, obviously. I peek over, the stroller's empty, I'm like, oh thank God. And then I'm like, holy shit, I'm on a cliff. I start looking down the cliff, I'm like, is there a parent with a baby down there? Nothing. Called the cops, took them 3 hours to come out there, freezing my ass off by the time they got to me. And they took the stroller and they said, we'll just do a missing persons or a missing property and we'll see if anything comes of it. Never did hear anything. Scared the crap out of me. Sorry, I don't know why I just told you that. You didn't need to hear that. You didn't need to hear that.